Welcome back, everyone. Thank you very much for being here for this last session of the day. I'm very glad to introduce you to our panel. So we have a discussion now about mathematics and climate environment sustainability within the industry and policy. So we have So I'm very glad to introduce you our panel for the day. We have first Professor Veronica Bowman. She works for Pebble. We have Dr. Karolina Rucinska. Is that correct? Oh, good. From Innovate UK Business Collect. She's a knowledge transfer manager, Net Zero Living. We have Angela Mathis from think tank Maths Limited. She's the CEO. And we have finally Dr. Thomas Hodgson from Credit Nature. He's the analytics lead there. So start with Ronnie, please.
So I actually work for a company that sequesters carbon in concrete. So the idea is you put in raw rock, and you put it through a reactor. The CO2 is sequestered in the rock. It produces cement out, which can then form concrete. So there is an actual viable value chain there for industry to make money while decarbonizing the construction industry. And I think that's key. We aren't going to change the way the world works overnight, but actually we can make a substantial change by taking what we do already, which is a lot of construction, and going, well, how do we do that better? And how do we incentivize industry to actually get behind that and make money by being environmentally friendly? And I think the role of mathematicians, my role in there, is to make sure that our life cycle assessment is carbon negative. So how do I ensure that the energy we're putting in is less than the energy that we get out? But also, how do we evaluate the impact? Where do we see the biggest gains? So where do we see the biggest problems, and what's going to really turn the needle in terms of making a difference? That's where mathematicians excel. That's where we spend our lives.
Absolutely. What are your views on that?
Yeah, I agree. Well, first of all, industry has a big impact on climate change to start with, right? Everything we do it creates carbon, has an impact on biodiversity and obviously population in which it employs. So I think mathematicians can really help with the with operations, help solve some of the problems. Basic things, most organizations don't even have a carbon footprint. So if you have someone really good at not just with numbers, but understanding what it means, how to calculate, how to solve it, that's one thing. So mathematicians can help, I think, with such basic things, but also help to see the bigger picture. The second speaker talked today about the non-financial disclosures. So many big industries around the world, including the UK, now have to start disclosing the impact they have on the planet and people, and also how planet and people affects them. So basically how climate and loss of biodiversity will impact their ability to basically make more money. And so be able to compute that, be able to understand those impacts is going to be of huge value to the businesses, because effectively they'll be able to get more investments, private investors or public investors. And so mathematicians can really help understand those impacts. And as we've learned, they're quite complex to know how does loss of biodiversity impact my company that is, for example, is just in the services. It provides IT services to other companies. That seems quite abstract. So I think mathematicians can really help to see that bigger picture.
Yeah, that's a very good point. And I will bring it now to Angela. You have the experience to work with several companies through your own consultancy. So what are your views on this?
Yeah, so one of the key founders. We've been around for 18 years, based in Edinburgh. We have a Norwegian subsidiary. And sort of 2020, we decided, because we were doing banking, we were doing lots of things, but in 2020, we decided there were two, it was probably COVID and lots of time to think about the world. And, you know, there's, you know, as I said before, there's, you haven't look up Dex Hunter Torike. He puts it very nicely, you know, the next decade is going to be the most disruptive in the history of humanity and of mankind. And you've got to decide, you've got a choice, you can position yourself. And I think that's really what we decided as a company. And, you know, find your brain trust. And I would even say that, you know, your brain trust is people that will come along with you. So we decided that we would focus on sustainability in space. So that's, you know, we can't just keep putting satellites up there. You know, we were 2,000 satellites about 5, 6, 7 years ago. We're now 13,000 satellites. It's well, you know, a conservative estimation is that in 3 years' time, there'll be 47,000 satellites, and a non-conservative is 200,000. And we're talking about lower Earth orbit. You know, we're talking about from, you know, that 330 kilometers. I mean, 330 kilometers, you wouldn't even get from here back to Edinburgh, right? So would you, you know, but, and to 2,000 kilometers. And it is a finite space. And we do not know, well, we don't know that we can't propagate properly. So we're working on that. We're working on managing the space environment. We're managing understanding how that impacts the behaviors of satellites as they're spinning at 8 kilometers a second. So space sustainability. But the other project and the other area we decided is energy, the energy transition. And that's a terrific project. We're working with Very Energy, and Donna Sutherland is heading that up, and the two of us are championing this. And what is that? So Very Energy has a project to work on, they want a contract to take the Sullenville terminal. So you can have, you know, there's the Grangemouth, you know, terminal. So it's traditionally oil and gas. What is oil and gas? It's a chemical industry, basically, right? You're taking naphtha out, you're doing stuff to it, you're transporting it around. So Sullenville terminal, I don't know if any of you've been to the Shetlands, but you know, if Sullenville terminal shuts down, the ecosystem of the whole of the island is dead, because you've got, you know, it supplies 70% of the shellfish around, you know, for consumption around the whole of the UK and exports. You know, mass amount of the population are reliant on the Sullenville terminal continuing. So Donna carries that very big challenge on her shoulders, and it's all about how do you transform from an oil and gas terminal into, by 2030, 35, into something which is sustainable energy. And together we sat down and talked about, okay, you can use wind. Now, Shetland is the windiest place on the planet other than Chile. It's the Saudi Arabia of the wind world. But if you have to curtail wind, because you can't, the choking point is the grid, and also it's very expensive. So how do you design a system that keeps off that? So how do you take wind, the wind energy, which is in abundance, and the concept that we decided, the constraint was, we will not waste a single gust of wind, and take it through to something which is economically viable. And that's where she brought us in as mathematicians. So we're not a think tank, we're a business. We basically use mathematics on projects. As we said, you know, some of the hardest, you know, it says some of the, if you look at our website, some of the hardest problems facing humanity, call us, you know, who do you call? Call us, and, you know, and we'll bring in mathematicians necessary for that, from ourselves and from elsewhere. So it's taking wind and turning it into drop-in e-fuels. So why drop-in e-fuels? Because, you know, ships and aircraft, I mean, you know, the fuels are used in all of our transport, and people are traveling even more than they did before COVID. So you don't want people to have to change the ships. You don't have to change, you know, engineer is engineer. If you've got something that's going to cost the industry a fortune to transform, then that is a problem. But again, to your point, this is so to do this mathematically, so we're actually proving that you can, you know, this is a system of systems, the interdependencies right through this entirely new chemical process. And so how do you prove that it's economically viable? So that it becomes an investable project, so that it becomes a repeatable project, so that it doesn't just happen on Shetland, but it happens on Flossa in the Orkneys, and it happens at, you know, every oil and gas terminal, if you like, across the whole of the UK. And why not even take that capability and send it abroad? So turning wind through hydrolysis, so that you've got a hydrolyzing process, but don't stop at hydrolysis. Take it all the way through to sustainable aviation fuel. And with the intermittency of wind, you know, your feedstock is intermittent. You know, and then also you've got all of the parameters, and you need potable water, and you know, and all of those things. So all of those uncertainties, all of that complexity is what we're having to deal with in order to prove that this is economically, we have a price point. There has to be a price point which is economically viable of that sustainable aviation fuel to be sold, and you know, and it has to attract investors, and otherwise this project is going nowhere.
Yeah.
So that's what we're doing.
But that's a very good point for this part of the discussion, because we both turn to Thomas, who works in a fintech.
So I work at a company called Credit Nature, and we are developing methods of quantifying what we call ecosystem condition or ecosystem health, with the goal of driving investment into nature restoration projects both in the UK and internationally. And so it sort of touches on a lot of the topics that we've been talking about today, where if you can't quantify something, you can't convince people to invest in it, basically, whether that's for any reason. So yeah, we're working on frameworks to develop that, and I sort of sit between the science and tech team, as mathematicians often do, sit between the gaps, where we provide the glue between different communication styles and different teams. But yeah, to move to the question of how I see the role of industry in addressing climate and sustainability environment problems, I think industry's uniquely placed compared to like governments, in that industry can afford to take a lot more risk because they can afford to fail in a way that governments can't. Like if a company goes bankrupt, that's not a problem for society. If a government goes bankrupt, that's quite a big problem. And so industry can provide the funding for these very innovative ideas that might pay off, but also very much might not. So for example, like Pebble or like ourselves, we're coming up with ideas that there's a good chance that they might not work or they might not be economically viable. And I think that's where what industry's role can be, is we can dump a lot more risk there that governments aren't willing to take. That's not to minimise the role of governments in providing the stick as well as the economic carrot that industry looks for. In terms of mathematicians specifically, I think obviously we're all mathematicians and we view ourselves as that, or statisticians. I think I'd want to just emphasise that mathematicians are people, and as people we have an ability to choose where we spend our labour, and I think that's what mathematicians should do, is look at the jobs that are out there and choose where they allocate their labour, and so that the skills that we're bringing, that we can bring them to bear on the challenges that we think are most important to ourselves. And I think that's the biggest difference that mathematicians can make. We've mentioned earlier on about like ethics and responsible modelling. I think let's stop looking too big of what can mathematics do. It's like, what can you as an individual do? Even if you're working in a hedge fund, which is my example of things that aren't very sustainable, there might still be steps that you can make to push for more sustainable movements. So whether that's, we all have an amount of freedom that we can take, and not everyone can choose to work for a company as fortunate as I am, where all of my labour is spent on improving the environment and sustainability. Not all of it, but quite a lot of it. But yeah, I think we should all look as individuals for what we can do to move the needle towards the things that we want to see in the world.
Yeah.
So I think mathematicians are kind of uniquely placed, and my role in Pebble is not to kind of, we know that the solution is economically sound, but what do we want to do? We want to prove that to other people, right? And what is basically the business of a mathematician is to prove things, right? That at heart, that's sort of what we do. We prove things. And you can't go into someone and go, it's economically viable. They're like, well, prove it. that's a mathematical skill, proving something. And you can do it from first principles, you can do it using data, you can do it using statistics. But I think the key thing is really understanding and getting under the skin of the question that's actually being asked. And we got a little bit of the complexity earlier, kind of we were talking about lots of different things. So there was the data center being dropped in the ocean. Well, that's great, unless you drop 1 million data centers in the ocean, and then you kind of accidentally heat up the ocean. So what's the question? The question is, how do I, without environmental impact, build a data center? Or kind of thinking about the animals. Well, what is the question? Actually, you want an ecosystem, and building that complexity in. We've already seen that as mathematicians, that's what we're good at. We're good at getting to the heart of what that question should be. And I think the role of like mathematics, the role of the SIG is about really kind of going, well, I know you've asked that question, but how do I actually understand what you want to know? And then how do I provide the information that allows it? How do I present it? I saw a really interesting, totally not environment, but a really interesting graph the other day. Those of you not a geek in the room, I'm sorry, it was a Star Wars graph, Luke Skywalker and a Starship Trooper, because Luke Skywalker was shorter. And they put the scale starting at 5'8". So Luke Skywalker looks like half the height of a stormtrooper, right? Because of the way the data was visualized. In actual fact, there was a difference of kind of 4 inches, not half. How do we communicate in a way that's both clear, so the pictures are good, we like pictures, but clear, and it is actually allowing someone to understand what we're trying to convey? And how do we test that? How do we prove it? I think that's key. And I'm really sorry, National Rail waits for no one. Thank you, it was a pleasure being here.
Yeah. Thanks for your brilliant insights. Yeah, and good luck with your train.
Mic drop all the brilliant.
Yeah.
My flight's 10 to 11 tonight.
Veronica has gone, but she left some, I think, very good insights, which I suspect is something you deal with it as someone that brings together businesses and academics for
well, first of all, I'm not a mathematician, so I always think that mathematical community can bring so much to the table, because you can open people's minds to things that others have not seen yet and considered. You have a let's face it, the world does like quantitative data, maybe a little bit more the qualitative. At least it says it does, unless it's the numbers show the answers they don't want to believe in. So then they move to the qualitative people. But I think that's again, so what Veronica, the point she raised was very important, is that you have ability to question someone's ask, you've got ability to question the reality, and you've got ability to arrive at a very different answer in very different ways and show possibilities. I think that's very unique way of doing it. You can compare things, you can visualize them, you can tell the information through so many different angles. So I think that's very powerful, more than anything, because if someone asks me, show me the data, show me the numbers and give me the answer, I'm like, I can't do it for you. I can tell you what people think, I can tell you what the narrative is, I can tell you how they feel about this, but I can't tell you that, you know, a percentage of these people said this and therefore you must go for it. Perhaps you can't do it either, but at least you can say how we arrived at that number. You can do it in a quite a powerful way. So I would say you have a very, very strong voice, but I suppose it's what we talked about earlier. It's good that if you understand other sciences and other points of view, then you can perhaps together arrive at one very nuanced answer. So listen to the other scientists, listen to what the industry wants, and I suppose get to the bottom of that question. Probably much more most interesting thing that you could do.
Yeah. So I can pick up from that. I mean, you just said work cross-disciplinary. in this project in Shetland, we are working with 12 original equipment manufacturers throughout that entire supply chain. So our mathematicians, because we have 10 mathematicians in Edinburgh working on this project. So we're working with the people that produce the hydrolyzers, the people that do the Fischer-Tropsch process that we're using. We're working with the wind turbine company. We've got all of the data, but we also understand, we're working with engineers, we're working with the engineers. So it's you have to be able to do that communication and understand, because we talked earlier about if your model will fail if it doesn't replicate the reality. And so you want the intricacies and you want to understand the complexity and what size is the matrix, etc. So that's really, really important. But your question is about policy. So this project is being supported by, it's the Net Zero Technology Centre in Aberdeen, and that is funded by both the Scottish and the British government. And it's very much seen, it's a very, very, so we've been talking about it on platforms at offshore Europe, where we're making sure, so this will be seen as very much as a test case. And mathematics is at the forefront, so it's going to be, if you cannot do this, you will not be able to, as you said, they're not able to say, for a start, Veri will not be able to raise the capital just on the back of an envelope. This is far too complex. It's unknown. It's a brand new chemical process. I mean, we're saying that this is going to be 90% of the CO2, because you use CO2 will be absorbed to make this sustainable aviation fuel, and it will clean burn, because you're not taking naphtha out of the ground and burning it, so you're getting clean air. So, I don't know if you've seen, but there's recently, they're seeing that some of the worst cases of Parkinson's and Alzheimer's are caused by air pollution. And so this will be a clean burning fuel. And so all of that is part of our narrative, which we are telling the governments, and they're watching this and they want to see the success of this. And we're working with, you're asking, so we're working with DESNES, and we're working with GB Energy, and we're working with, we're informing and we're engaging them also. So not just all of the original equipment manufacturers making the entire process. So there's a large swathe of the industry is coming into this, but there's also, as I say, we're working with the policymakers. NESO is the National Energy Strategy Organisation. They're actually writing the strategy for Scotland, for England, for Wales, whatever. And we very much are keeping them included and informing them of the viability of this project. And mathematics is the centre point, and they understand that. This would not be doable without there. So I think that's the kind of thing that I think mathematics has to be doing. Rather than doing it in a closet and answers come out, where it really is, it is something, but it is, it's center stage for a very viable solution, which allows to that's 500 jobs in Shetland, right? Imagine those 500 jobs. I always say, you've heard of, there's the spaceport up in Shetland, right? We've got the spaceport up in Sullenvoe, up in Saxaford. That area, if you look back and look at Saxaford and Lambinets, in 1900, it was a bustling fishing area. It was absolutely, there were, ships coming in, there were canning factories and whatever. There's a bit of flotsam and jetsam sort of attached to the jetty now. It's gone. So the entire island of Shetland, which is, it's a 2-hour flight from Edinburgh up into the North Sea, that place just becomes an absolute ghost island if this doesn't work. And the Shetland Island Council nor the Scottish Government is going to have that happen. So I think that's where you have a societal impact. It's fantastic. Look at the careers and look at the impact you can make. But I think to your point, you have agency in this terrible 10 years that's going to come at us. And you have agency to decide what you do with your mathematical competence. And as you say, you can do it within a fund or you can do it within an organisation, but you have agency in order to achieve what you think the vision of the future should be and what you want it to be. And that's really what we're offering to our staff, and that's what we're offering to the people that are working with us.
And back to you.
Yeah, I think I could only echo what's already been said around the influence comes behind like people put a lot of trust in numbers. Sorry, non-mathematicians put a lot of trust in numbers, probably more trust than they should do. And as mathematicians, it's our responsibility to provide that narrative and that context, because otherwise people will trust these numbers too much. So it's almost your job to be like, here's a solid answer, but here's all the times it's wrong, and here's everything around this that means that this won't be correct, which generally policymakers and decision makers don't like so much. But yeah, definitely being able to communicate that narrative. And the other thing I'd echo is like understanding the language that people are speaking from different domains, or understanding the constraints of the system in which they're working. So the policy environment and the government environment is very different to when you're working in private industry or even in academia. We work quite a lot with an Australian group called Accounting for Nature, who have worked like accredit our ecosystem condition methods. And they're a group of ecologists, and they would talk with our ecologists and they'd be speaking the same language, but they wouldn't mean the same things, because they've been trained in an Australian ecological environment. Like they're thinking about, well, there's no large mammals. Is there no? Yeah. Like the ecology of Australia is obviously very different to what it is in Europe. So even there, we're like, well, we've got the same job title, but we still don't understand each other. And so it's, again, trying to bridge that gap between different languages, even when you might expect a common and shared language. And sort of linked to that is just understanding the people's worldviews and the context that they're coming to a problem with, so that you can better answer the question that wasn't the question that they asked, as was alluded earlier. And also understand your worldview that you're putting into your models. Like, what assumptions are you making? What do you believe about the world that is being encoded in this model? Again, I think there's this like myth of objectivity around mathematics, that it's this like pure subject, and you get taught at university that these are the right answers. This is a proof. This is categorically correct. That just doesn't hold in the real world. And when you come to create a mathematical model, you're already making assumptions. Sometimes you write them all down, but more often than not, you don't. And that's where the friction comes when you're trying to discuss with policymakers. And I think that's where the language of mathematics becomes very useful, because you're like, number one, these variables are all IID. And the policymaker will be like, well, I don't understand that, but it's definitely false. But being able to write down your assumptions a priori and discuss those assumptions with the people that you're developing the model for, I think could lead to a really interesting conversation about, yeah, your worldviews and your value systems before you get to the programming. And that's where sociology and communication comes into it once again.
Yeah, absolutely. And you, Ross, please.
Yeah, quick question on the aviation fuel. Have you already got airlines engaged as well? You know, sort of any particular ones, even if you can't name them, but sort of thinking of testing, and because again, you know, this is a very safety critical industry, but it's a real issue, is it, having sustainable aviation fuels, obviously.
So we've got a list of targets. We've got a list of targets because if you can understand at the moment, so we're in phase 1. And phase 2 of the project's about to start. So we're not quite at putting nuts and bolts and things on the ground just yet. You know, this is going to take up to, you know, even a pilot plant, about 150 million to build. So, but we're warming up, and a lot of the communication we're doing is obviously engaging and letting people know that this is coming down the pipeline. I mean, we're not to give away, but you know, the results of phase 1 are, you know, promising. Let's put it that way. But we're engaging with investors and folks. So part of that dialogue, but we haven't got anybody signed up, but we've got a couple of what we've had dialogue with, and they, you know, there's an obligation for the aviation industry to, I think it's up to, is it 3 or 4% they've got to move to, and some have already stated, I think Air France has already said they'll do 10%. You know, because it's all about supply and bringing that, you know, bringing the product to market and being where you are. But the beautiful, actually, all of this is backed on what we are thinking. We did a piece of work for a large Norwegian, the biggest Norwegian energy company, which is a state company, and it's on the premise of distributed energy systems. So a whole new way of thinking of energy. You know, rather than having a big power plant, a gas, you've got coal-fired power plant. You actually create, if you've got wind or you've got solar, whatever your feed is, and then you turn this through and you're looking at what the demand side is of that hub, that geographic territory, And then what can it generate? So you've got these distributed energy systems. And then you can start to look at taking this sustainable aviation fuel and having it around where, for example, if we were to do Grangemouth, then it's a beautiful place to be supporting Edinburgh Airport and Glasgow Airport. So we're already thinking in those terms and talking to the stakeholders there. So there's a lot of groundwork preparing. This is real disruption in a positive way. Yeah.
And geographically, you're generating it as well, and you've got a completely different model.
Yeah, because in the south of England you'll have more sunshine. Certainly, if you look at the weather in Shetland, it's
Yes. There's a question online.
Okay, we've talked a lot today about our roles as wranglers of equations and data. We're often described in society as trusted messengers. As individuals, do you feel we have a role beyond our maths?
Yeah, of course. Of course we do, because after all, we're all human. We live on this planet. We will die on this planet, and we impact this planet, and the planet impacts us. So we have a huge role to play to reduce our footprint and make sure that we don't impact others. So that's 100% true. We've got a lot to play. I think, as we probably all know, our impact comes from travel, use of energy at home, and food we eat. So if you do any of those things, think how you can change that. And that's it. It seems very simple, but it really is that.
Yeah, I'd reiterate my earlier point, as mathematicians are people.
Yeah.
We're not computers or calculators, we're not deterministic, we're not organised and act the same way and act rationally. We're still very irrational human beings. Like, of course, there's a role beyond that for mathematicians, and I also think that's the real value going forward. When people do look to large language models to solve all of their problems, they're not providing the context and the narrative, they're not providing the softness that a person can. And I think that's, again, the value of having a human there, is that ability to communicate beyond just crunching numbers. I think that is.
And I can only iterate what I said. I mean, if the future, everybody's got whether it's small angst or big angst about the stuff every time you switch on the television, then you have agency. And as a mathematician, you have agency. You have one of the most powerful underpinning sciences. Yes, you must make sure that people, because how many times have our team, and you've got the engineer on the other side saying, but give me a number. We say, no, we can give you a range. No, but we want a number, but I give you a range. Because we haven't got enough data to be able to make that statement. Don't make us, you're asking for something would be false. So I think be bold, don't be cowed into sort of just pacifying and giving the answers people want to hear. But I think there's also, you can choose what you do with the knowledge that you've acquired. And you just have to. There are more problems than you can shake a stick at, to be quite honest today. And does that sound very west of Scotland? But so if you want to be, you can have a quiet life. You can I hear people want to find an island somewhere and go and have a bothy somewhere and make and grow their own fruit. That's fine. That's fine. Do that. You probably won't have a big footprint of flying, etc. But do it in your own way. But you have agency, and having mathematics and choosing the people that you work with and the projects that you want to work on. Don't settle for less. Decide what you want the world to be, and then work with like-minded people. So I'm going to use Dex's words. Find your brain group. So find them. It's called brain trust, and then use that agency, that choice that you have in terms of the job that you do. So you can influence hugely. You can if you choose.
Thank you. Kara is thanking you for answering that. I think it's about time, but before we end, I want to ask you a last question. We're talking about agency. For many people, agency might be conditional on money, for example, and we recognize that. So my last question is about money. So supposedly, I was about to give a very large grant for you to work on any aspect of climate, environment, and sustainability. So how would you spend it?
Tipping points.
Where's Melo? He's gone.
Unfortunately, we haven't.
You get a share of that.
Planetary boundaries and the tipping points, and most importantly, the positive tipping points, is the work of Professor Tim Lenton, which I've just learned about. There's actually a global report coming out, 2025 soon. And there's a report by Institute of Actuaries, again, talking about the risks, how they've been underestimated. And I think that if I was a mathematician and I had this amazing computational power in my brain, I would ask for funding and work on that. How can we scale up those tipping points? How can we predict them? How can we identify where they are, in which ratio and proportion to the negative tipping points, and how to identify those tipping points? So we can identify this ghost in the data. I absolutely love that presentation. So I encourage all of you to look at the planetary boundaries, because that's crucial, because climate change is only one of the planetary boundaries that we've already crossed. There are 9 planetary boundaries. We've crossed 6 out of 9, which is quite scary. And also we need to understand how those once those boundaries are crossed, how they impact on the life of the humans, right? Yeah. Because I think we're only concerned about that. And also just I want to add some just a food for thought. The reason I think we have mathematics is because for the last 10,000 years we had the Holocene, which is the only time when the planet has stabilized. This is when people actually sat down and started, raising stock, and they started counting who owes whom what and how much. And that's how mathematics have really started. It's because we had this stable system of our planet, and that system is about to collapse. And I think maybe without this we wouldn't have mathematics. So maybe by saving planet we can save mathematics.
Nice incentive.
Well, yeah. I mean,
isn't it?
Well, yes, because
Think
without
about
it, it'll just be conjecture and a lot of hot air, to be honest. So you were saying, what would you spend the money on? Well, I screamingly agree. I mean, I think these are. I think there are, one of the things in space, and that's the sustainability of space, is what is the carrying capacity of lower Earth orbit? And if you ask this even to astrodynamicists, because they're not mathematicians, you see, but if you ask them to say, can you calculate, and it's huge, because the system is very complex. You've got space weather, you've got also, hey, it's a nice complex environment. It might be too big a bit to chew off, but I think to understand, are we at the limit with 11,000? There's some great professors in the UK have said we're already crossed that threshold on that. We've already got the Kessler effect taking place. We just don't know, because we don't see everything that's up there all at once. Kessler effects where satellites are smashing into each other, and then they're causing debris that's smashing into others. And they think the Kessler effect has already started. So there's an area as well which has got to do with sustainability. But I think everything you've said is absolutely right. Just spend it on those, the tipping points.
If 2 satellites smash into each other and end up in more bits, do you have more satellites or less satellites?
If you want a satellite, the definition of a satellite is to be something that's beaming information back to Earth, and it's a dead satellite. It's a fragmented piece of, it's multiple pieces, thousands of pieces of useless junk, which are very, very dangerous. And I wouldn't be doing a trip to space with, like getting on an aircraft and saying, here you are, could you sign here to say if a piece of debris flies through the fuselage and kills you, that your family won't come after us. And the stuff is going to fall back down to Earth as well, and fall through our civil aviation space as well. I mean, this is the other thing which is not hugely understood. The whole area of space and the stuff we're doing. And it's a shame, listen, it's an absolute shame. I was in the space sector when it was exciting and inspirational and whatever, and now it's become a militarized zone, and it's become a zone of human almost folly and unfettered sort of, let's put satellites up there, and too bad if they just, we'll just let them burn up and come through the atmosphere. We could be destroying the atmosphere. We could be causing problem on the ozone. I mean, these are all problems that you could buddy together with you know, with chemists and with astrodynamicists, and do some fantastic work on what is the impact of satellites deorbiting and burning up as they come back through the Earth's atmosphere. These are huge problems, and you need mathematical brains to do them.
Yeah.
To work in conjunction with others.
Yeah. Oh,
And fund them.
I think for me, working in industry and trying to get people to put money on the table, the biggest language that people speak is generally in risk. And these risks are very well understood when it comes to what you call NatCat, so natural catastrophe, things like hurricanes, floods. People are willing to take out insurance against floods, companies. What I think is really not well understood is biodiversity risk, and how do we assign risk to biodiversity to individual companies? Because at the minute you've just got sort of a tragedy of the commons where everybody views nature and biodiversity as something that you can just take from and exploit. Perfect example earlier, Microsoft can just sink their data center in the sea and they don't have to pay for cooling. And you're like, yeah, but we as a society will have to pay for that cooling.
Ecosystem services, right?
Exactly.
Providing that.
Fried fish for everything.
Yeah.
So I think what I would do is, yeah, try and take a grant and try and really nail down more the quantification of biodiversity risk, because I think that would be the tool that would start to grease the wheels more in terms of actually costing on companies' balance sheets what the risk is to them. Or just more moonshot would be to spend more money to try and understand ecosystems and ecosystem dynamics. Like we talk a lot about the laws of physics. I still don't think we've got a good grasp on the laws of ecology.
Yeah.
And I think that's fascinating. I think that would be a really exciting space for maths to start to move into. Obviously, mathematical ecology is an established field, but to really get more people excited about that and moving into that. And that's what I sort of see going forward is like in the 90s and 2000s, mathematical finance was the exciting place to work and it really revolutionized that industry. Then we saw like the tech boom and everybody wants to work for fan companies. What I'm hoping now is that the next boom in mathematics and PhDs and undergraduates is mathematical ecology, mathematical biology, and environmental studies. Yeah.
fingers crossed.
For the betterment of humanity, we really need it.
Yeah.
Seriously.
Definitely, and I think that brings us for a nice closing, because the SIG is all about that. It's about bringing us together to work together, bring us with this common interests to leverage our potential really as mathematicians, as people interested in mathematics, as a society, and practitioners as well. So I would like to thank our panelists once again. Veronica's not here. Karolina, Angela, and Thomas, and thank everyone again for staying here up to the end, to the online attendance as well. Thank you very much. And just before we thank everyone once again, I want to say just a few words. This is the first event that we put it together, so this officially marks the launch of the SIG. So we hope to have you engaged with us throughout the years and helping us to shape the SIG going forward. So this event we spent the past few months planning it as the newly formed SIG. So I want to thank first of all everyone that's here, that's been here, both online in person, or panelists or speakers that volunteered to be here, and the IMA for offering us the opportunity to have this group and for partially funding it too. We, as I asked about funding, it would be great, but funding is always an issue. We have limited funding, and this event was actually only really possible due to a very generous support from UK Business Connect through Dawn. So I want to thank them as well, and the colleagues from LMS and the Morgan House for the venue, and finally to my colleagues at the SIG for all this for all the work. We've been working a few years to put this together, and it's finally coming true. So we hope that it pays off for everyone. And yeah, let's thank the panel once again.
And thank you as well.
Yeah.
Now to what matters, reception, food and drinks.
And shows.
Thank you.
Thank you.